What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And we are official with doing this March SAT from 2020. Now, it's kind of interesting because I believe it was Nubist who requested this. I'm just quickly checking my sound. Okay, my sound is good. So Nubist was the one. Hey, there you go. You're the one. Hey, you're back. Yeah. So you mentioned that this test wasn't actually solved yet on my channel, and so I was like, wait, I'm sure I did this. So I looked, but I couldn't find it either. Some people say, hey, I did do it, and it's up there, I guess, somewhere, but I couldn't find it. So, hey, it is what it is. We're doing it again. Even if you have seen it the first time, I still think this is of huge value to just kind of like watch me do it in real time. And because I'm not just doing it, obviously, I'm going to explain as I go along and kind of tell you guys how to approach it and whatnot. What's up, Rabab? And hey, Shak Zodbek. Hopefully I pronounced that right. X-Legend, and have a great day. What a cool name. My day is going very well. How about you? And hey, that's amazing, Andre, and so happy to hear that. By the way, so two things I want to talk about before we jump into the test. So no worries, Nubis. So the first thing is Koshik asked, hey, where can I learn all the rules? I sent the playlist up top of the critical concept videos, and the critical concept videos, I gotta say, are probably one of the video series that I'm one of the ones that I'm most proud of. Not the most, but like it's up there because it's got everything, right? When you talk about rules or concepts or whatnot, it covers everything. So if you need to cover your bases, and if you haven't watched that series yet, especially as August is coming up, the August SAT, I would do that immediately because you can fill in the gaps. Yeah, it's going to take like 3-4 hours to do it, but you'll get everything down, done, explained, and you can move on. The other thing is somebody asked in the comments section, hey, can you guys tell me, does this stuff work? Do these video series help? And what I wanted to say about that is, I mean, yeah, of course, if you want, you can look at all the comments. You can look at the video testimonials. You can see that people have gained their scores, but it doesn't even matter. And I want to bring this point home because I am not on this channel trying to sell a particular methodology and say that these tricks work, this system is the best, blah, blah. Because I don't have to sell anything, because what am I doing on this channel? I'm teaching you just the straightforward multiple ways that you can do. I'm just basically straight up just teaching you the math. So there's no system to be evaluated. There's nothing. It's just, will my channel work for you? That depends on if you like my teaching style. If you feel like you come away from these videos understanding more than when you first watch it, then it's a win. And if you don't like my teaching style, then there's probably somebody else that's better suited for you in terms of how they explain or whatnot. That's the key. That's the test. So it's an individual question. Check out my stuff, see if you like it. And if not, no worries. I take no offense to it. We're all on here trying to improve the sphere of education in the digital realm. Anyways, okay, let me say hi to a couple people here. Is it okay to study more than one math topic? Yeah, for sure. Emmanuel, what's up? Dana, hi. Hey, Xavier, do you think August SAT will be hard? It doesn't even matter. It's an irrelevant question, because if it's hard, then the curve will be nicer. If it's easy, then the curve will be tougher, but like, you know what I mean? So they balance it out. You should be able to find this on Reddit. In the past October, do you think the October are easier by chance? It's really hard to say. The College Panda, or yeah, what is it? I think basically he's got a whole image of like past SAT curves, and it's all over the place in terms of difficulty from the different test dates. Let's get 800. Yeah. English tips. So we're doing more English videos now. I got Rosie on that. She's going to be doing more stuff. Nubis, thank you. And okay, guys, we got to get started. So let's do this. I'm going to switch it over so you can see the timer, and there's also the calculator section. So if I did take this, then I'm not taking it for the first time, but I couldn't remember the first one exactly. So if I did indeed do this, so I technically am not taking this for the first time, but it's meant to be like a first-time attempt, where I'm taking it in real time so you can see me solve and problem solve and think in real time, which will be similar to how you have to do it on the test. I got the calculator queued up, and here we go. We're going to start in, wait, let me get the right thickness here. It's too thick. Let's go like this. All right. We're going to start in 3, 2, 1. Let's do it. S equals 4. What's the value? Plug and chug. Boom. 4 times 20 is 80 minus 15 time, oh, I could have simplified, but that's all right. 15 times 4 is 60. 80 minus 60 is 20. Boom, done. You could have also been like 20s minus 15s is 5s. 5 times 4 is 20. Also valid. Number 2, the line graph shows the number of space shuttle launches by the United States from 1981 through 1986. During which year of this time period was the number of space shuttle launches the greatest? Well, it's right here, 1985. It's pretty straightforward. Reading a graph, line plot-ish. Boom, done. Numero 3. I wonder if I should zoom out a little bit. I feel like this is too zoomed in. Okay. American marsupials and Australian marsupials are shown. 2 pioneering groups of marsupials. The table shows the number of species in each order, blah, blah, blah. Okay. Based on the table, what fraction of the Australian marsupial species are from the order this one? So what fraction of this? So you see now there's a subset. We're not talking about the whole thing. What fraction of the Australian marsupials is this one? So that means it's 24 out of, and you could use a calculator again if you want, calculator section, 72, 92, 96, 98, 198, 98 plus 137. I'm going to write it out. 5, 12, 13, 2 out of 235. I believe I did that math right. Let's see, 24 out of 235. Boom, done. Just let me read it one more time. Based on the table, what fraction of the Australian marsupial species? Yeah. We've got it. Number 4. 10 data points are in the scatter plot shown, along with the line of best fit. Which of the following best estimates the predicted value of y when x equals 6.5? So here would be 6.5. Pardon my line. Boom. It looks like it would be 16. Boom. Done. We're using the line of best fit. That's the predicted value. Numero 50. What is 120% of 2,000? That becomes, to take that percentage, we turn this into decimal, 1.2 times 2,000, which would be 2,400. Boom, done. Numero 60. A field has a perimeter of 960 meters. Okay, so we're doing feet to meters. So we got 960 feet converted to meters. So it says 1 foot. Why am I putting the feet on the bottom? I want them opposite so I can cross cancel. Equals 0.3048 meters, and then the feet cancel out. Now all we got to do is just multiply, right? That's how I like to do. You may have been like, obviously you multiply. What are you doing? But I always like to be a little more methodical with my dimensional analysis. 48, right? Is 290. Boom, done. 7. Box and whisker plots. They keep getting tested more and more in the SAT, so you got to know these. This is the min value. This is the max value. This little line in here is the median. Those are the most important things to know. Then this is the upper quartile, and this is the lower quartile, that little thing. So those are the 5 values. Which of the following could be the median annual cost? See, they're trying to test the median. Looks to me like 1625 is the winner because 2,000, no. 2,100, no. Like, whatever. It doesn't even matter. Let's just make sure we're answering the right. Which the following could be the median annual cost. Okay, yeah. We're good. Numero 8. The table lists selected values of Sam's walking speed in kilometers per hour and his corresponding pulse in beats per minute. Hold on. Table lists selected values of Sam's walking speed. Oh, okay, got it. So when he's on there, that's the beats, that's the beats, that's the beats. Good. There's a linear relationship. Aha. So every time this goes up by 2, this goes up by 10. Yes. So the slope is 10 over 2, a.k.a. 5. Which of the following equations describes f of x, and f of x is the pulse, a.k.a. the y value? I already told you what the slope is, right? It's the change in y, 10, over the change in x, 2. So 10 over 2, which is 5. This is the only one with the right slope because that's -5, -1, and 1. It's got to be this, but let's just double check. Let's plug and chug. So if I plug 4 in here, I do indeed get 77. If I plug 6 in here, I do indeed get 87. Okay, that's good enough for me. Let's move on. Numero 9. Based on the 2010 U.S. Census, the population of Milwaukee, Wisconsin was about 96% of the population of Baltimore, Maryland. So I'm going to put that in an equation. Wisconsin was, a.k.a. equals, 96 of Baltimore. In 2010, if Milwaukee's population, I should say Milwaukee, not W. if Milwaukee's population was this, which is the following list the approximation for B more? Okay, so you see what I'm doing? Set up my equation. I don't even have to think now. I just plug and chug. 595,000 equals 0.96B. Isolate, we divide by 0.96. Boom. 595,000 divided by 0.96 is 620. Done. Let's get the timer back up here. Okay, 49 minutes left. In 1855, Louis Rem traveled from Sacramento, California, to Portland, Oregon, stopping to rest for only 10 hours of the 143 hours, which means he traveled 133 hours. If his average speed while traveling without resting was 5 per hour, how many miles did he travel? So I already removed the 10 from the 143, so he traveled for 133. And if he's going 5 miles per 133 hours, it's literally 5 times 133, right? Rate times time equals distance, and that would be 665. But you can use the calculator if you want. I'll just double check. Booyah, 665. And we're done. 11. Interval 1 to 10. Blah, blah, blah. Okay. Each of the 25 data values in a set has different integer between 1 and 50 inclusive. The table gives the frequency of the data for 5 intervals. Yes. Which of the following intervals contains exactly 2/5 of the values in the data set? Well, here's the dealio. It's 25. So first of all, what is 2/5 of 25? Cancel, 1, 5, 10. So which range has 10 if you combine it? Well, this one, 31 through 50, and that's right there. Just make sure nothing else. 21 through 40 would be 11. 11 through 30 would be 8. 120 would be 12. Numero 12. The table shows the distribution of the number of extracurricular activities that students at a middle school participate in. If the number of... Okay, let's look at this first. So 5% do nothing. 30% do 1. 55% do 2. More than 2, only 10%. The number of students who participate in 2 extracurricular activities is 120 more than the number of students who participate in 1. So 2 is 120 more than the number of students participating in 1. So if 1 is x, this is 120 plus x. So that means that 25%, right? Because this goes up by 25%. That means that 25% is 120. So I set up my percent proportion. 25% of the total is 120. Now we can simplify this to be, I just set a percent proportion, cross. Of course, it's going to be 480 is the total. And that's it. That's what they're asking. And now we can just quickly here, I'll just verify. So 30% of 480 is, let's do a calculator, just see if we have time. So this would be 144. 55% of 480 is 264. And that indeed is 120 more. So far that works good. 10% obviously is 48. And 5% is half of that, which is 24. So I'll quickly add them up, make sure it adds up to 480, and we'll move on. 168. You don't have to do any of this, by the way. I'm just showing you just for fun because I feel like I got a lot of extra time. 168, 368, 428, 432, plus 48. Yeah, it's 480. All right, cool. 13. For her job, Natasha spent a total of N minutes processing ID card. Oh, let's look at this first. Number of driver license applications processed, 27, 24, boop, 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 linear. Number of ID card applications processed. So it's like, as these drop, the ID card process drops as well. Okay. And driver's license applications. It takes Natasha 15 minutes to do an ID card. And so I'm going to put that with the ID in 20 minutes to do a license application. The graph above represents all possible combinations of number of ID applications Natasha could have processed in N minutes. What is the value of N? What? Hold on. Oh, which could have. That Natasha could have processed in 10 minutes. Wait. Oh, it's probably the same. Oh, I get it. It's the same every time. I was like, wait a minute. Well, it could be multiple. No, it's not. I can choose any of these values. So, for example, I'll do the easiest one. 27 times 20, assuming she only did those, is 540. And I bet you it's the same for every single value, right? So here it would be 4 times 15, which is 60, plus 24 times 20, which is 480. So it's, again, 540. So every combination is taking 540 minutes. All right. So yeah, I think I was looking at this wrong. As this number drops, she's doing more of these. Drops, doing more of those. I think I incorrectly stated that at first. Okay, let's check the time. In the xy plane, what is the y coordinate of the y-intercept of the equation? Blah, blah, blah. Okay, y coordinate of the y-intercept occurs when x equals 0. So 0 times 3 is 0 over 0 plus 2. That irrelevant. Negative 12 over 2 is negative 6. Boom, done. Should we double check it? Nah, we're good. Okay, 15. The coordinate of points A, B, and C are shown on the plane of which of the following inequalities will each of the points A, B, and C be contained? Will each of the points... so they're all contained in the solution. Okay, y is greater than negative x minus 2. So that would look here. Y, and then it would be a line like this. Y is greater than negative x minus 2 would be everything up here. Yeah, A is the winner. All right, but let's try these other ones. Y is greater than or equal to negative x. That would come like this through here. And greater than or equal to negative x. It would include this. It would miss this one. So B is out. Again, we don't need to do this. I'm just doing this just for fun. Y is less than x plus 3. That would be like this. So because it's less than, this would actually be a dotted line. And again, we'd catch these two, but we'd miss this one. So that's out. And then x is less than 3. That would be a dotted line here. And again, it would capture these two, but it would miss B. So A is the winner. In the figure above, AB equals AD. Always mark it up, right? BC equals CD. It's a kite. BE equals 2. BC equals 4. And AC all the way across equals 10. Let me mark it like this. Okay. What is the area of triangle ABD? So this whole triangle here. Wait, let's highlight it. That's terrible. All right, sweet. What is the area of this triangle? Well, I know that this, since it's a perfect kite, right? I know that this side is also going to be 2. Well, I'm kind of making some assumption. I could prove it, but let's just, you know what it is, right? You know that these are right angles. Diagonals of a kite are congruent, are perpendicular, you know, whatever. But you can tell. You don't even need me to like, you don't even need to know that rule, but it is. Okay, and that is for AC is 10. Wait, I need more. What else can I deduce from this? AC is 10. Hold on. BC equals CD, AB equals AD, and then BE equals 2, so that's 2, triangle ABD. Hold on, I gotta think. That's 2, that's 4. Pythagorean's theorem? Can I do Pythagorean's theorem? Oh, I can, over here. So over here I can do it. So I can figure out this side and then subtract it from 10. So it's 2 squared plus x squared equals 4 squared. X squared equals 12. X equals square root of 12 is 2 rad 3, right? Because it's 4 times 3, so it's 2 rad 3. So if this is 2 rad 3, this section here is 10 minus 2 rad 3. So now we can do the area, which is base 4 times height, but it's also half of this, right? because you have to take half, right, for a triangle. Half base times height. So half of 4 is 2. So then let's just write 2, and then we distribute it, and I get 20 minus 4 rad 3, and there's the answer. It's a pretty hard question. All right, 17. The graph above shows the distribution of number of years of experience for 25 teachers enrolled in advanced degree program. Distribution. So there's 4 of them that have 1, 7 have 2, 8 have 3, 4 have 4, and 2 have 5. See how I write it out like that? That always helps me. If a 26th teacher with 2 years of experience is added, so it'd be here. Can do better than that. What will be the effect on the mean and median? All right, first of all, let's figure out what the median is. So it's 25. So the median's going to be the 13th value, the middle value, so 11. So the old median is 3. What's the old mean? Well, hold on. If this would then be 8. So the median's not going to change. The new median is still going to be 3, because if this is 8, now we have 26. Now the median's going to occur between the 13th and the 14th value, because it's an even number, right? So we have, and the 13th value would still be here, and the 14th value, so it'd still be 3. So that's out. Median will remain the same. That's out. Okay. So now the question is, obviously the median changes. You're not going to add a value unless it's equal to the mean. Okay, there's a chance it could. If the mean is 2, then the mean won't change. It's probably going to decrease, but let's calculate it anyways just for fun. So the mean is 4 times 1, which is 4. 7 times 2, which is 14. 8 times 3 is 24. 4 times 4 is 16. 2 times 5 is 10. So I'll just do this mentally. 38, 42, 52, 62, 68. So the old sum is 68 the old mean is 68 divided by 25. 68 divided by 25 equals 2.72. And then the new one, we would just add that 2. So now it's 70 divided by 26. So the new mean went down. So the mean will decrease as we kind of thought. Okay. 18. A sports store had 60 backpacks in stock, some with wheels and some without wheels. Before a new shipment of backpacks arrived, the number of wheeled, and then I'll say O for no wheels. I don't know. The number of wheeled backpacks in the new shipment was twice the number of wheeled backpacks already in stock. So this is new shipment, I guess. Okay, and in stock we have X. And the number of backpacks without wheels in the new shipment was 5 times the number that was already in there. Sorry, I keep clearing my throat. After the new shipment arrived, there were 330 backpacks in the store. Okay. Before the shipment, there were X wheeled backpacks. Oh, look at that. We did the variables right. X wheeled and Y wheeled. Which of the following equations can be used with X plus Y equals 60 to solve for X and Y? The second one, which is 3X, because it's everything. They said after the new shipment, there were 330. So X plus 2X is 3X. Y plus 5Y is 6Y equals 330. So I would say this would be the equation that we would use, but they don't have that. So, okay. So the next we would say 2x plus 5y. It doesn't equal 330. It equals 270 because that's what the new shipment is. Because they said after the new shipment, there were 330 total because you have to add it to what was in stock. So 2x plus 5y equals 270, and there's the winner. Let me just make sure. Remember I told you yesterday that I think this is going to have to be hard to balance out the no calculator section? Like, this is a really hard calculator section, I think. It's very difficult. And I can tell also based on how much time it's taken me. The function h is defined as shown. For what values of x does the function reach its minimum value? I know you might think this is hard. And it is. I'm not saying it's not hard, but here's the deal. Here's this really important shortcut. If this is an intercept form, I know then the intercepts are at 5, and -5. And if that's the case, the vertex is going to be in the middle of these guys. What's right in the middle of -5 and 5? 0. And guess what? This is obviously like, it's going to be x squared. The x squared term is positive. So it's going to be going like that. So the vertex is the minimum. So for what value of x does it reach its minimum value? 0. Now, what is that minimum value? It's -25. But they're not asking the function value. They said, for what value of x does it reach its minimum? 0. Boom, done. 20. A set of data is represented by the scatter plot in the portion of the xy plane. Which of the following linear equations best fits the data? Hold on. First, okay, this line tool is always the one thing I don't like about Miro. It always does this. So I have to reset it and do all this. But I do think it's important to draw a line here to kind of get a rough idea of like what the best line. Okay. So that's what they're talking about. They're talking about modeling this with the line of best fit. And with my line, what I'm going to do is I'm going to, I'm going to extend it. Let's get that nice y-intercept. So we know we have a y-intercept of about like 92. Wait, what? Oh, no, we don't. Sorry. This is at 5. We don't even know the y-intercepts. Forget the y-intercept. Let's just come up with our own equation. We'll see which one it's closest to. Okay. So I'll do 5.295. So first I'm going to calculate the slope. And let's do this imaginary point. 6.8125. 6.8125. Now I'll calculate the slope by subtracting down. 95 minus 125 is -30. Over 5.2 minus 6.8 is -1.6, right? -1.6. So -30 divided by I'll say 30 divided by 1.6 is 18.75. Rut-row. 18.75. None of them have a slope of 18. Oh, they have a slope of 16. All right, close enough. So you're out. That's the wrong slope. So 16, whatever. So I guess my line's probably like a little off from what they use, but I think my line's pretty good to be honest, but it is what it is. So it's got to be 16. Now the question is a y-intercept of -15.2 or 15.2? It's probably negative I'm just wildly guessing, but let's now actually evaluate it using point slope, and that will kind of give us an idea. So remember, point slope, I'll choose any one. I'll choose the 95. How about? Y minus 95 equals the slope of, let's go with 16 since they said it's 16. No, let's go with my slope. 18.75 times x minus 5.2, right? I just chose this value to plug in. And then y equals, we got 18.75x, 18.75 times 5.2, and that's negative. And then we add it. Oh, sorry. It's negative. Oh, this is not good. It's too close to call. It's like, but the y-intercept is going to be right in between these guys. So my line of best fit is really not like what they're looking for. 5.295, 6.8125. I feel like I picked pretty good points, but that would be negative. That plus 95 would be negative 2.75. I mean, I'm feeling like it's this. I mean, what did I do? I feel like my line of best fit's pretty sweet, but what could I have? Would it be more like this? Hold on. Let's get rid of this. I should really do this one more time because it's like, it's too close to call. You know what I'm saying? Let's see if we can do a better one. I always feel like I'm threading the needle, right? Wait. Let's get rid of this too. Okay. Maybe like this? Okay, I don't know. Something like that maybe. And then 5.6, 100. Okay, 5.6, 100. And 110, 6. 110, 6. I'm just going to do it super fast. So the slope is 10 over negative 0.4. I mean, sorry. 10 over 0.4, negative 10 over negative 0.4, which is 100 divided by 40, so it's 25. Again, my slope is off. See, it's too steep now. But then if I did that, I think that would now give us this this negative, man. I don't know. I guess, oh, here's another thing we can do. Let's quickly plug and chug. How am I doing on time? So I guess I'm throwing a bunch of different methods here, but let's quickly plug and chug just to verify. Like I said, I'm pretty sure this is right, but I think we have the time, so why not? If I plug in 6 into this one, I would get 96 minus 15.2. Ooh, that's so low. 96. So if I plug in 6 into this one, I get 96 plus 1 plus 15.2, which is closer. Now I'm starting to change my mind. And then, okay, this one. If I plug in 5.2 here, oh, I'm starting to go the other way now. I'm starting to go the other way. I'm feeling like now this is the answer. Because I'm just not getting good values when I plug in. And then it's really strange. I'm not sure. Okay, 6.4. Let's plug in one more. 6. This is like 6. Let's plug in an easy one I can do mentally. Okay. 6.4, 6.8. Let's say 6.8. This is about 7. 7, if I plug in, is 112. Yeah, I'm feeling like this is it now. Because these will all just be wrong. Man, like I said, it's a hard test. Okay, 21. Let's move on. And I got to keep the timer up because I'm being a little too careless with my time management. The equation of the graph shown is this, where A and B are constants. What's the value of B? Let's put it into slope-intercept form, right? So I get BY equals negative AX plus 6 divided by BY equals negative A over BX plus 6 over B. Boom. And then my slope here is up to over 6. So it's a slope of 1/3. What is the value of B? And my y-intercept is negative 2, which means, B is negative 3. Right? Because 6 over negative 3 is negative 2. And that would make A negative 1. Okay. Not that they need A, but hey. We're cool, right? With that, what's the value B? Good. 22, the function W gives the estimated weight in pounds of a rainbow trout based on its length in inches. Okay, so this is just an exponential equation. 1.22, so in here's the change, either increasing or decreasing. This one is increasing exponentially because it's over 1, and it's changing by a percentage, and 1.22 is like 122%, so it's like increasing by 22% every year. It says for each 1 pound in weight. Well, hold on. Estimated weight in pounds of rainbow trout based on its length. No, so for each 1 inch increase, the weight increases by 22%. So this is backwards. Yeah, these are wrong. I know it's going to be a percent. For each increase of 1 inch, like we said, the rainbow trout increases by 22%. Boom, done. 23. In the given figure, theta is an angle. Perfect. If sine of theta equals root 3 over 2, what is cosine of theta? First of all, cosine is negative in quadrant 2. So you're out and you're out. It's got to be this because it's not the same. The only place where it's the same is when it equals square root of 2 over 2. That's for 45. But like you don't need to know the unit circle, but you can do this if you want. Okay, so you'd be like, here's theta. Sine of theta is, remember it's opposite over hypotenuse. So if that's 2, that's root 3 using Pythagorean theorem. 3 plus what equals 4, that's 1. So we know it's a 30, 60, 90, but it doesn't matter. Then what is cosine of the same angle? It's adjacent over hypotenuse 1/2, but it's in quadrant 2. Cosine's negative quadrant 2. Boom, done. Wait, it's at 23. 24. The two-way table categorizes the change in values of July and August for 50 stocks. Got it. If one of the stocks that increased in value in August, so one of these guys, is chosen at random, what is the probability that the stock also increased in value in July? Wait. What? Oh, yeah, one of these is chosen at random, so we're out of 30. What is the probability that it also increased in July? 21. 21 out of 30, which I believe is 0.7. Booyah. All right, 25. Minato drove 390 miles. Part of the drive was along local roads where his average speed was 20 miles. Okay. Local roads where it was 20 miles per hour. And the rest was along a highway where his average speed was 60 miles per hour. The drive took 8 hours. What is the distance? Okay. Here's the dealio. What is distance equals rate times time? It's a simple formula, but an important one. So we can set up an equation here because, hey, like, you know, I can go, we know that the total time is that, right? Well, if I know that distance equals rate times time, I know that distance divided by rate equals time. Well, check this out. This distance, I don't know, but I'm going to call it x. This one is 390 minus x because the two together make 390. That's pretty cool, right? I could do a system of equations, but I'm just like cutting out the middleman. So now we got that distance divided by 20 plus this distance divided by 60 because that gives me the time. And time equals 8 hours. All right. So now we got a nice little equation. Let's get rid of the fractions, multiply everything by 60. That becomes 3x. That becomes 390 minus x, the 60s cancel out, equals 480. 3x minus 2x is 2x. Whoops. And I'm going to simultaneously subtract 390 from both sides, and I get 90, and that means x equals 45. And that's local roads. Boom, done. This one would be 390 minus 45, which is 345. Doesn't matter. Yeah. 26. In the quadratic equation above, b is a constant. For what values of b does the equation have only one soluciones? 8. Wait a minute. It's 8 and negative 8. Because 8 definitely works. I'm going to show you why, but 8 definitely works. So if this doesn't, it's got to be 8 and negative 8. But anyways, here's why. If it's 8, it factors to x plus 4. That's a single, or double, you can say a double root, but a single solution of negative 4. That's only one solution. Also, if you did minus 8, it would factor to minus. So the two solutions, or the solution would be 4. All right, 27. Function f is defined for all real numbers in the graph y equals fx and xy plane is aligned with a negativos slopos. So a negative slope is like that. Hold on, the function f is defined by xy plane with the line negative. So which of the following must be true? If a is less than b, a, it's to the left of b, so that's the x values, right? Then f of a, that's the function value, is greater than f of b. If a is less than b, that is correct, right? No matter how you dice it, if you have a negative slope, it's going to look like that. If a is less than 0, then f of a is greater than 0. No, that's not true because negative slope, like, I could just move this down. You get what I'm saying? And then now f of a, even though a is negative, f of a would be negative. So this one is out. And numero, well, first of all, 1 is true. So you're out and you're out. So now it's 3. Okay. If a is greater than 0. No, again, it doesn't mean anything. At some point, it's going to probably go negative. But like, what if a is right here? F of a would still be positive. You're out. 1 only. Hoping I understood that or didn't go too fast there. Okay, we got to go. I think it's down here. Were we on 29 or something? 28. In the equation above, a and b are positive constants. A does not equal b. How many distinct x-intercepts, aka what values of x, send this to 0? Okay, so 1 would be a. That is also a because a, is 0. Also, we have x in front, so that's 0. And then we also have negative b, and we also have positive b. So they said distinct. So this is a double root. So 1, 2, 3, 4, boom, done. 29. In the given equation, k is a constant. If the equation has no soluciones, what is the value of k? When it's no solution, what we're looking for is we're looking for identical slopes. Okay, so basically like identical x values, and then one has a constant that the other doesn't have. So I'm going to distribute the 1/3. So I got 1/3 x minus 1/3 k equals kx. So the equation has no solution. That means these guys need to be matched up, and then we have an extra thing here that will always throw it off. But that's the main idea. So then k has to be 1/3, and you're done. That's it. You could test it if you ever wanted to, because then it'd be, I got time, I think. 1/3 x, 1/3 times that is 1/9 equals 1/3 x. And then now anything you plug in like 9. You'll get 3 minus 1/9 equals 3. Not true. Plug in 10. You'll get 10/3 minus 1/9 equals 10/3. Not true. It'll never be true. No solution. The expression x squared plus bx plus 10 and x minus 3 squared plus c, where b and c are constants, are equivalent. What is the value of b plus c? Oh, they're equivalent, a.k.a. set them equal to each other. I'm going to FOIL this. X squared minus 6x plus 9 plus c. These are equivalentes, which means goodbye, goodbye. And that means b has to match up with this because that's the only other x term. So b equals -6. And this 10 has to match up with 9 plus c because those are two constants. So c equals 1. So -6 plus 1 is -5. All right, sweet. 31. What value of x makes the equation above true? 3. Because 3 minus 3 is 0 to the 4th power is 0. It's done. One and done. 32. In the data shown, r is an integer. If the median of the data set is 8. Let me first put these in order. 4, 5, 5, 8, 11, 13. 8, 11, 13. If the median of the data set is 8, that means 8 has to be in the middle. And that means r has to be like somewhere over here. Like it could be there. It could be anywhere over here, but it has to be in the upper half. It says r, and r is less than 11. 9. It could also be 10, and it could also be 8. So any of those. 33. If xy is the solution of the system equation of x. All right, got it. So we're solving for x. Look how nice this is. It's beautiful. It's all we have to do is multiply the top equation by a negative and combine. So -4x plus 8x is 4x. The y's cancel out. -4 plus 5 is uno divided by, or isolate divided by 4. X equals 1/4. Just for fun, we had the time. Let's solve it. So 1/4 times 8 is 2. 2 plus what equals 5. Y is 3. So now we'll check this one. 1/4 of 4 is 1, plus 3 is 4. Boom, done. Double verified. 1 serving of a certain brand of microwave popcorn provides 150 calories. Okay. 90 fat. 60 other. I don't know. Other. 1 serving of a certain brand of low sodium pretzels provides 120. This is popcorn. This is pretzels. Both have to start with P, right? Okay, and it is what it is. 120, 12 of which are from fat. 108 are from other. Not that, maybe that doesn't even matter, but whatever. How many more calories from fat are provided? How many more calories from fat are provided by a 100-calorie serving of the microwave popcorn and 100 serving of the... Got it. Okay, what we're going to do is basically... So you see that 100 is 2/3 of 150, right? So all I have to do is take 2/3 of this fat, and I got it. So for the popcorn, I can do that mentally. 2/3 of 90 is 60. For this one, it's 100 out of 120, which is 5/6. So 5/6 times 12 is 10. Again, you can use a calculator if you want. 5 divided by 6 times 12 is 10. So how much more? It says how many more calories from fat? 50. Okay, 35. Pretty difficult question, actually. Deceivingly difficult. It seemed not so bad, but it's just confusing. The length in meters, the sides of the height, the parallelogram, the area in square meters, the parallelogram. Okay, parallelogram, we just do base times height. That's it. Very straightforward. It's 50. We don't need this value, and we're done. The other way to think about it is if you kind of like remove this triangle and plop it over here, it's a rectangle, so it's 10 times 5. If you need that, if you forget the formula for area of a parallelogram, you can sort of deduce it like that. 36. The linear function f defined by this, if f equals that, no. Okay, what is the value of c? Plug and chug. So first I'm going to plug in 50 for x and 27,000 for the function value. This is really just function notation. So 27,000 equals c times the 50 plus d. That's 1. Oh, it's a system of equations. System and function notation hybrid. This is 38,000 equals c times 100 plus d. What is the value of c? Look how nice this is set up. As long as you just plug in and take a second and look around, you're like, oh, the work is done for me. Because now I just negate. The d's cancel out. Negative 50c plus 100c is 50c. Just moving the order. And 38,000 minus 27,000 is 11,000. Last but not least, divide by 50. Divide by 50. 11,000. Hold on. Divided by 50 is 220. Boom. All right. 2 more. 37. A large company has 19 mainframe computers of a certain class. Okay. 19. The scatter plot above shows the value and age for each 19 computers. So if the age is 3, the value is 20,000. So obviously as it gets older, value goes down. That makes sense. A line of best fit is shown. Okay, I think we are, that's what I like to do. I like to really understand the scatter plot and the graph and the setup before I just jump in and then like, okay, wait, now I have to go back. That's always harder for me. Based on the line of best fit, the estimated value of a 6-year-old computer is $1,000, where K is an integer. What is the value of K? Okay, it's pretty straightforward. Based on the line of best fit, it's right there. It's 15,000, and it says that in K thousands of dollars. So 15,000, aka K is 15. 38. What is the number of computers for which the line of best fit predicts a value less than the actual value? So the line of best fit predicts something less than the actual value, aka the line of best fit should be below the dot. Wait, what? Oh. Sorry, what is not for the year? Okay, what is the number of computers for which the line of best fit predicts a value less than the actual value? So hold on, let me erase that dot because that's going to confuse me. So we're looking for all the dots that are above the line of best fit. Yeah. So these are the actual values, and the line of best fit is the predicted value. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. And we are done with 11 minutes to spare. All right, let's go ahead and stop the clock. I'm not going to check anything now. If you're taking this for real, obviously, don't do what I'm doing. Check your work. See if you can find any mistakes. And I mean, there are some that I probably should look at again, that like that scatter. You know what? Maybe I will look at it again. Nah, it's fine. If I got it wrong, it's whatever. Oh, let me just quickly look at it before I check. Where was it? Here, I'll keep the timer going. Well, it was that... It was this one. I seem to really be having some trouble on this one. I don't know why. My normal method, which is, I mean, it's pretty fail-safe, but it just wasn't working. So here, let's see if I can do a better line of best fit. Maybe I need it to be more shallow like that. Like that, maybe? Okay, let's try this. It's a pretty good line of best fit. Okay. Now let's choose 2 points. Let's choose 105, 5.6. Sorry, backwards. What am I doing? 5.6, 105, and this one, 6.6120. Well, look at this. Already the slopes are looking better. Maybe, I guess I just drew a really bad line of best fit. So that's negative 15 over negative 1. So it's a slope of 15, which is really good because that's close. So I'm probably on the right path. And then now we'll do point slope. So I'll just choose the second value. Y minus 120 equals 15 times x minus 6.6. And then distribute. I think that's 99. Yeah. So it's 15x minus 99 equals y minus 120. Then you add 120, and it's y equals 15x plus 21. So I guess D is right if I look at it that way. So what I had was, I think, correct. Again, the backup method I used was I tried to plug and chug and see what happened there. All right, let's check the answers. Let's zoom in a little. Wait, close this. All right. And then I'll go back to the chat and look at what you guys are saying, because see if there's any questiones. All right, we've got DDBD. DDBD. Then I've got 5 is CBAC. CBAC. Then I've got 9 is AADB. DB. Then I got 13 is BAAC. C. 17 is CBCD. 21 is ABCC. 25 is BDAC. Wait, 28 was C, right? Yeah. And then 29 and 30. Wait, 29 and 30 is D and D. Yeah, those are all correct. Amazing. All right. Now let's look to the free response. So we've got, we've got 3. We've got 9 as a possibility. Remember I said 8 or 10 would work. We've got 1/4 or 0.25 decimal equivalent. We got 50 and 50. 2 in a row. Didn't even notice that it was 50 and 50. That's funny. 220, 15, and full Z win 9. Oh yeah. Let's see what we got in the comments. All right. So, and wow, we got a nice little audience. Oh my God, thank you guys so much for those 40 likes. That's so awesome. Thank you so much. Hold on. Nubist, what's up? Ask where you got this from because, wait. I don't know. I always get these on Reddit because those are usually the publicly shared ones. And this is a release test. I double checked too. There's other YouTube videos. So this definitely should be on Reddit somewhere, but not sure where. In my recommendations, it showed up in my recommendations. What's up, BuzzFeed? Can you solve more real tests? Yeah, of course, Sarah. I'm going to be doing a ton of that in leading up to this next one. Can you explain 27? 27 decreasing slope. Oh, where was 27? Hold on. Wait, wasn't it up here? Yeah. So decreasing slope, you know it's going down from left to right. So I just drew a random line like this. You could have also drawn like here, you know what I mean? I just drew one example. And then once I know that, like, it gives me a really good idea. So they're like, hey, A is less than B. Well, if that's the X value, right, because they're plugging into the function, it's to the left, right? And then so you can kind of start to piece it together and see what they're talking about. It's very difficult because this is so abstract. So I need a drawing. Otherwise, I have no idea what's going on. Everett, thank you for that. I've worked hard to get this fluid with these tests and be able to do it this fast and even with the explanations, right? Like, not trying to say anything like, wow, I've gotten so good, but not a lot of people can do what I do in terms of the real time and explain it in the real time. I think there's one other channel where they basically do the same thing. That guy's pretty good, but like, how am I able to do this? Because I practice so much, like an insane amount. I couldn't do this before when I was in high school, even though I did pretty well on the test, but now I gotten really into the flow. We are not cheating, BuzzFeed. This is a old test from a year ago. What do you use to write? This is not cheating. Hold on. Okay. Yes, Everett. Let me see if we've got other ones here. Instagram videos. Yeah, you're welcome, man. I thought this is a super hard test. Super hard. You have a fantastic day as well. Muhammad, what's up from India? My family's from India. I'm just quickly looking. Yeah, you can do plug and chug. That's always an option. I'm from Turkey. I know these pronunciations. I don't know English so well. Yeah, we got more videos coming out very soon on English. Okay, a lot of comments. So guys, here's the dealio. This was amazing, and I'm glad to do this. And I hope you guys enjoyed this video. If you did, please click that like button. If you want to see more videos on SAT math leading up to the SAT, if you really want to go for the gold and really study hard, subscribe, because we got tons of content. Like I said, we're going to do a hardcore series of live streams leading up to the SAT, which will really be excellent for everybody shooting for the stars. And that's it. Follow us on TikTok. Go to TikTok and follow Math Puzzles. That's our new TikTok account. We're really trying to get that bigger and get more people fun math puzzles to help get them solid with their math understandings and whatnot. Thank you guys so much for joining, and I will see you in the next video. Take it easy.